Hi there. Well, it's time for volume. Let's have a look at this shape. You'll recognize right away that it's a triangular prism that's been copied. The congruent pair of the triangular prism has been flipped 180 degrees and connected with the original triangular prism. Now, the neat thing about this technique is it's the same technique we use for calculating area of a triangle. Because if we wanted to find the area of the triangle, by copying the triangular face, flipping it 180 degrees, and connecting it with the original triangular face, we created a parallelogram. And then, if we take a step back, parallelogram could be further trimmed. You could decompose one section after creating a perpendicular off of the base. We could decompose this section, move it over to the other side, and effectively create a rectangular face. Then we'd have to divide the area of that rectangle by 2 to find the area of the triangular face. So we're talking about area, which is represented in square units. So when I say square units, I mean if you look here, that's a square. That's 1 square unit. So the next step is to take our square units and see how they relate to cube units. Well, a square is one face of a cube. The cube is a 3-dimensional structure created from square units. So the only difference is now we're taking the flat square and we're including another dimension. In this case, it would be height. Some people will call it depth, and we can call it a stacking layer. So when we find the area of the parallelogram, in this case, to start, once we find the area of the parallelogram, to find its volume, we have to add another dimension. So the area is calculated in square units. Volume will be calculated in cube units. So how many cubes would be used to make up this entire shape, not how many squares. Now the easiest way to find the volume would be to find the area first of the base, and the base would be a face of your object, a face of your solid, that has a perfect copy, a congruent copy of itself on the other side of your shape. You'll notice it's right here. So this could easily represent the base because there's another one of them on this side, and it's exactly the same. Could we use this as the base? Is this an exact copy of it? You'll notice if you were to try and cut it into cube sections, they're not exactly the same, and you can tell by looking at it on this side. But you could be creative and slice the shape here and then bring this section up top. And what would you get? Well, you'd have cubes here, and you'd have more cubes you'd have 2 sections of cubes. So that's another way of solving the problem. Again, for double checking, it's important to try and solve the problem in many different ways. Let's go back to this original one because it easily ties into the tasks that we've been working on in the past. So if we were going to try and find the volume of a triangular prism, you can copy, as I said earlier, the triangular prism, connect it with a congruent copy of it, and then look at the base, and then try and calculate the area of the base. Why? Because it'll tell us how many square units that can be found on the base. Once we find the number of square units, volume is just simply taking that square unit calculation and figuring out how many stacks there are, because the stack represents another dimension, and the stack represents how many cubes are in or connected to that base. Essentially, how many square units are being extended to create cube units, because they're just simply taking the base face and increasing its height. Make sense? So here's a quick demonstration. If I was to draw a base, and this base is a triangle, again, if I'm going to be creating a volume, right now the base is simply, that's an area, if we were to find the area of that base. But to make it volume, I would have to extend it by a certain number of layers, but it's still the same face. See, that area of the triangle is still there. To find the cubed volume, all I would do is take the area of the base and then multiply that by the number of stacks I have here, thereby creating a cubed dimension, or a third dimension, which is called volume. So let's go back here and have a look at our shape again. The area of the base, as we've done in the past, this is a parallelogram. The base is 2 units. The height is 3 units. Base times height, 2 times 3, 6 units squared. That's the area of the base. So that's the number of square units you see. There should be 6 units squared total. That means 6 of these squares will make up the base. How do you find the volume? Well, if there are 6 units squared on the base, and there are 3 units in stacking layers, well, 6 units squared on the base multiplied by 3 stacking layers, or 3 units, 6 units squared times 3 units equals 18 units cubed. The square unit multiplied by the stacking unit, so that would be unit squared times unit to the exponent 1. So it would be, you would have to add the exponents, 2 plus 1, which equals 3 cubed now. So that's units cubed. So your unit converts from a second dimension to a third dimension. Hopefully this helps. Good luck.